this question is a typical question on Faraday's law and Lenz's law, and you are told that the magnet is dropped into the coil, and as it enters the coil, the galvanometer, which measures the current, the direction of current and the magnitude of current, deflects towards the right. So you're asked when the magnet is leaving the solenoid from the bottom of the solenoid, what will we observe in the galvanometer? The answer to this question is B. The deflection will only be a snap deflection, a very sharp deflection. It wouldn't be continuous because of Faraday's law. There must be a change in the magnetic field that the coil experiences before an induced EMF is generated. So when the magnet is within the solenoid itself, the solenoid, if it's long enough, it will experience the same magnetic field, and therefore without any change in magnetic field, when the magnet is inside the solenoid, there will not be any induced EMF. Only when the magnet leaves the solenoid, then there is a change in the magnetic field that the coil is experiencing. Now, with regard to the direction of the induced current, why is it opposite compared to when the magnet is falling into the solenoid? Now, when the magnet is falling into the solenoid, as you can see, the top part of the solenoid will want to be an induced north to repel away the incoming north pole. So, therefore, the direction of induced current, if you use a right-hand grip rule, will be as such. And this, as we are given in the question, gives us a deflection in the galvanometer towards the right. Now, when the magnet is now leaving the solenoid, as you can see, the bottom part of the solenoid will want to have an induced north in an attempt to try to attract back the south pole that is moving away by Lenz's law. So, as you can see, the polarity of the solenoid is not different, opposite. If you use right-hand grip rule, the direction of the induced current will therefore be opposite in direction, and this explains why the deflection of the galvanometer is opposite when the magnet is falling in versus when the magnet is dropping out. Again, right-hand grip rule is very useful here to figure out the direction of the induced current. Okay, so this is how we should coil our right hand for these two scenarios. Do a double check on this if you need.